Hello, this is Mr. Wyrick, and I'm here today to talk to you about Lesson 7.5, the parts of similar triangles. There's a few different theorems that we need to talk about. Number one is 7.8. If we have similar triangles, these go back to those special segments of triangles where we had the altitudes, the angle bisectors, and the medians. You don't necessarily have to remember the in-center, orthocenter, all of those different things where they meet up. Of course, you know that'll probably come up on another like semester exam, but we'll make sure we go back over those as far as vocabulary is concerned. But this has to deal with those particular segments. So in the first one, we're talking about corresponding altitudes. Be careful on this. It's not just an altitude from triangle to triangle. If it's a similar triangle though, the way these two are, and I chose ones to kind of illustrate a point, they have an altitude that's outside of the triangle. But if these two triangles are similar, the corresponding altitudes, no matter where they are, from that angle, a 90 degrees down straight, the corresponding altitudes would be proportional to the corresponding side. So if this is a 2 to 1, then the altitudes would be 2 to 1. On 7.9, and I had to add corresponding, the similar triangles that have, this is in the wrong spot, corresponding angle bisectors, those are proportional to the corresponding side. So if this is like a 3 to 2, then this angle bisector, the length of it would be 3 to 2. And then in similar triangles, they have corresponding medians that are proportional to the corresponding sides. So those would go through like this. Those medians, cut that opposite side in half, and the length of the median would match up. So if it's 5 to 4, this would be 5 to 4. Okay, those ratios stay true even to the special ones. Now these are all kind of grouped together. You can see how they fit. There's one more thing that we need to go over, and that's 7.11. If we have the angle bisector again, then the different parts that it has split that triangle. This would be triangle ABC. And if AD is an angle bisector, then CD, this portion of the bottom here, CD is proportional to DB in the same ratio that AC would be to AB. So those sides, those full sides are in the same proportion as the split sides would be. So if this side is 7, this side is 8, then this side would be some manner of 7 to this one's 8. Depending on what the measure of that side is, you may end up having to go to decimals, stuff like that. Now, there have been a shortage of people actually sitting and watching these videos, and I don't have too much of a problem with it, but I do want to make sure that you're pretty well informed. So, for watching this, your reward is you will know ahead of time that you are to do numbers 6 through 26 and 30 through 34 from lesson 7.5. So when we come to class, you'll already know which ones to do. You can sit down, you can get started on those, and we'll see you then.